Hi, we are Group 7 for module Data Science Principle. So for this module, our objective is to develop a machine learning model that predicts a binary outcome, such as survival or non-survival by using a provided dynamic dataset. So for question 1, we need to conduct an appropriate exploratory data analysis EDA to get more insights about the Titanic dataset. This df.head code shows the first 5 rows of the Titanic dataset, which the index is from 0 to 4. For the code print df.tail, it shows the last 5 rows of the Titanic dataset index from 886 to 890. The following is data frame.info functions is used to display a concise summary of a data frame. It provides essential information. The following is df.shape functions used to get the dimensionality of the data frame. It has 891 rows and 12 columns. The following is print df.columns shows the columns of Titanic dataset, which are passenger ID, survive, passenger class, name, sex, age, sibling, parent, children, ticket, fare, cabin, and embark. The following is print data frame data types. It shows the data type for the Titanic datasets, such as integer, object, and float. The following is print df.describe. It's used for calculating some statistical data like count, mean, standard deviation, percentile, mean, and max of the numerical values of the data frame. The following code is used to calculating statistical data like count, unit, top row, and frequency of the top row of the categorical values of the data frame. The following code is used to show the sum of null values for each variable. The variable's age has 177 null values, while cabin has 687 null values, and embark has 2 null values. The following is the bar plot, which title distribution of passenger class shows the number of passengers in each class. We can see that the third class has highest number. The following bar plots titled distribution of sex shows the number of passengers based on their gender, male more than female. The following histogram titled distribution of age shows that the majority of passengers are between 30 and 30 years old. Beginning at around 70 passengers, the distribution is right skewed. The following figure shows a count plot highlighting the distribution of siblings aboard. It shows that the frequency of passengers with no siblings aboard is the highest, with a count of 600. The following figure shows a count plot visualizing the distribution of passengers with parents or children aboard. It reveals that the frequency for passengers with no parents or children aboard is higher, with a count of roughly 700. The following histogram plot visualizes the distribution of passenger fare. The cost for the plot removes any missing value to ensure that the distribution will not be affected by missing values. Moreover, kernel density estimate KDE is included in the plot to aid a smooth estimate of the data distribution. The following count plot shows the number of passengers in each class. It helps visualize how passenger of class affected survival rates, showing the first class passengers have higher survival rates compared to the second and third class passenger. The following count plot shows the number of passengers by sex. It reveals the higher proportion of female passengers survive compared to the male passengers. The histogram shows the distribution of age for passengers who survived and those who did not survive. The red histogram has a larger area under its curve. It indicates a higher number of non-survivors in those age ranges. The last histogram shows the distribution of fares for passengers who survived and those who did not survive. This plot helps identify patterns in survival based on fare, indicating that higher fares are associated with higher survival rates.
Okay, let's discuss handling missing value in our dataset. First, we input missing age value using the media, which is reduced to outlier and effectively represent the central tendency. We replace the 177 missing age value with the median using the FUNA method. For the embark column, we use the mood to input the two missing value, ensuring data consistency for categorical data. Okay. Due to a sensitive missing value, we drop the cabin column to maintain dataset quantity and reduce noise. Next, we encode categorical variable using one hot encoding for the embark and sex column, transforming them into binary column. This allows the machine learning model to process categorical data effectively without assuming any ordinal relationship. After that, in order to normalize the range of independent variable, we focus on feature scaling. The age and fair column are scaled using scikit-learn standard caller, providing transform column with a mean of 0 and a standard deviation of 1. For machine learning algorithms that are sensitive to dataset. To evaluate our model, we split the data into training and testing set. We define X into include all column except survive, name, ticket, and passenger ID, and Y as our target variable survive. Using the train test split method, we create training 80% and testing 20% set with a random set of 42 for reproducibility. We create a correlation metric by removing unrelated column and calculating the correlation coefficient. Visualizing this metric with a heat map helps us identify relationship between variables. Last, in the heat map, a correlation of 0.018 indicates the weakness relationship, while 0.549 represents the strongest, guiding us in feature scaling, selection, and model building.
So for question 3A, our objective for K-mean clustering models is to identify group of passengers with similar characteristics on the Titanic using K-mean clustering. First, we need to do data preparation. We select only numerical columns from the dataset as K-mean requiring numerical input. Second, we have to determine the optimal cluster, so we calculate the within cluster sum of square WCSS for cluster ranging from 1 to 10, and we use the elbow method to plot WCSS value. So we have determined that 3 clusters were optimal based on the elbow method. And you can see on the left-hand side is the graph of the elbow method for determining optimal number of clusters, and the right-hand side is the code base. So now we can see this is the scatter plot for K-mean clustering model, and the right-hand side is the code. We aim to identify distinct groups among passengers using the K-mean algorithm and outlining and provide insight into passenger demographic and their fare pattern. We started by initializing and fitting the K-mean models with 3 clusters. After fitting the model, we added cluster label to our data frame. Each passenger will assign to a cluster based on their characteristic size and fare. This allows us to categorize the passenger into distinct groups for further analysis. To visualize the clustering, we create a scatter plot of edge versus fare with point colored by their cluster label. The cluster centroid will mark as red star, providing a clear indication of the central tendency of each cluster. So for cluster 0 is for predominantly younger passengers who pay lower fare. This could likely include third-class passenger or crew members. For cluster 1 is for passengers of varying age who pay medium fare. This could likely include middle-class passenger from the second class. And cluster 2 is for older passengers who pay higher fare. They are the first-class passenger representing the wealthier demographic. So any question here?
Yes, there's question here.
Yes.
So for K-means fit, why need to include sibling and parent children?
So including sibling and parent children into the K-mean can improve the accuracy of the clustering. More features provide a higher dimensional space for clustering, which allow the model to find more distinct and meaningful clusters.
Thank you.
Hello, I want to ask what is the advantage of using K-means?
So for the first advantage of K-mean is known for its computational simplicity and efficiency, which make it suitable for large dataset like the Titanic. It handles diverse data attributes such as age, fare, class, and survival status quickly. And the second, scalability. K-mean can effectively manage high-dimensional and extensive data. This capability is crucial when dealing with large datasets. The algorithm allows experimentation with different number of clusters. This flexibility enables detailed analysis of passengers group by socioeconomic status, family connection, and more. So the third, K-mean is also higher flexible. It adapts to different data type and varying number of type of clusters. This flexibility allows us to cluster data based on various feature revealing underlying pattern. This adaptability is particularly useful for sociological and historical inquiries into passenger experience and survival on the Titanic. Now, I will discuss the evaluation metric and performance of K-mean clustering with you. We'll explore the silhouette score, Davis-Baldwin index, and Kalinske-Harbers index. So we can see the above is the code and the below is the result of the three metric we use. So first, the silhouette score is a measure of how similar an object is to its own cluster compared to other cluster. A score of +1 indicates well-defined cluster, 0 indicates an object is on the boundary, between cluster and -1 indicate that objects are likely misassigned. In our case, a silhouette score of 0.2865 suggests moderate cluster definition with some overlap and room for improvement. So second, the Davis-Baldwin index evaluates the average similarity ratio of each cluster with its most similar cluster. Lower value indicate better separation and completeness of cluster. A DBI of 1.4347 in our case suggests moderate clustering quality with some overlap and weaker separation between clusters. So the last one, the Kalinski-Harabash index measures the ratio of the dispersion between the cluster to the dispersion within cluster. Higher value indicate that the clusters are well separated and compact. Our Kalinski-Harabash index of 170.0069 suggests good clustering quality. However, it is important to compare this with other index and clustering methods to determine the best configuration.
Let's see the insights of the result of K-means clustering model. Cluster 0, which is super in color, covers a wide range of age and fare values. Many of them are concentrated at lower fare values, indicate various age who paid low fare. The points in cluster 1 that is in teal color concentrate at lower fare values and they are more density packed. Cluster 2 is in yellow color, contains smaller number of data points. It focuses on a narrow age range and mostly lower fare values, indicating a distinct subgroup. Cluster 0 and cluster 1 are partially overlapping, indicating that while there is some distinction, the separation is not very strong. On the other hand, cluster 2 is more distinct due to its smaller size and specific age range. Hence, we can conclude that most individuals paid lower fees. There are some outliers with higher fares that can be seen in cluster 0. Next, you can compare age and fare with other features that is age and patch, which means parent-children using K-means clustering model. For cluster 1 that is in purple color, is primarily seen at lower patch values. Cluster 1 in teal color include data points across a similar age range, but with higher patch values. Cluster 2 in yellow color has fewer data points, but it's mostly at higher patch values and at a narrow age range. We compare both of the models with different evaluation metrics, which are silhouette score, Davis-Baldwin index, and Kalinski-Harabash index. Silhouette score for age and fare is higher. This shows that the age and fare are better defined and have more distinct clusters. Davis-Baldwin index for age and fare is lower. This shows that they are more compact with better separation. Lastly, the Kalinski-Harabash index for age and fare is higher. This indicates that they are more well defined and separate a better dispersion ratio. Hence, we can conclude that age and fare outperforms age and patch, and indicates that they are more effective features. We'll discuss about the main clustering components and identify the most challenging part. One of the components is data representation. It selects features that best represent the data. Next is distance metrics. It measures similarity or dissimilarity between data points. The choice of it can reveal different structures in the data. Clustering algorithms are different methods to group data points. The evaluation metrics can evaluate the clustering quality. Besides, the scalability and efficiency are also important for handling large datasets. Clusters also have to be interpretable and visualized to provide an insight into the structure of elements. One of the most challenging parts is overlapping clusters. It indicates an improvement in the clustering algorithm or the selection of the number of clusters. There's also some difficulties ensuring the clusters are dense and well separated. Feature selection and pre-processing can be challenging. They are critical for effective clustering. Lastly, interpretability and scalability are also challenging. They interpret the clusters meaningfully and ensures that the clustering model scales well with large datasets. Thank you. This is the Q&A session.
I have a question here. So for K-mean cluster, why numerical data we choose age and fare for variables?
This is because age and fare has lower correlation score compared to the others. The features with low correlation scores tend to provide more diverse and independent information. It can help the K-means algorithm to identify more distinct, meaningful clusters. Using features with low correlation can lead to more stable and robust clusters. Thank you so much.
Thank you.